Picture this, you're driving a car, foot on the gas pedal, craving more power. Suddenly you feel a surge of acceleration, a kick in the pants that pins you to your seat. That, my friends, is the magic of a turbocharger. In simple terms, a turbocharger is like a supercharger for your engine. It's a device that forces more air into the engine, allowing it to burn more fuel and produce more power. Imagine blowing on a dying ember to reignite the flame. That's essentially what a turbocharger does for your engine. Turbochargers are becoming increasingly popular in modern cars because they offer a win-win situation. Increased power without sacrificing fuel efficiency. It's like having your cake and eating it too. But how does this magical device actually work? Let's dive in and explore the fascinating world of turbochargers. At the heart of every turbocharger lies a dynamic duo. The turbine and the compressor, these two components are connected by a shaft, forming a symbiotic relationship that is key to boosting your engine's power. Think of the turbine as a windmill, but instead of wind, it's driven by hot exhaust gases exiting the engine. These gases spin the turbine at incredible speeds, reaching up to 150,000 revolutions per minute. That's faster than a blender on high. Now, remember the shaft connecting the turbine and the compressor. As the turbine spins, it also spins the compressor, which sits on the other end. The compressor acts like a powerful fan, sucking in ambient air and compressing it to a higher pressure. This compressed air is then forced into the engine's intake manifold, where it mixes with fuel and ignites, creating a much bigger explosion and generating more power. It's like giving your engine a shot of adrenaline. We've established that the turbine spins the compressor, but where does the turbine get its energy from? The answer lies in the engine's exhaust gases. As the engine burns fuel, it produces hot, high-pressure exhaust gases. These gases are usually expelled into the atmosphere, but with a turbocharger, they're put to work. Instead of exiting directly, the exhaust gases are directed through the turbocharger's turbine housing. The shape of the housing and the angle of the turbine blades are designed to maximize the gas flow and spin the turbine efficiently. It's like harnessing the energy of a raging river to power a water wheel. The faster the engine spins and the more fuel it burns, the hotter and faster the exhaust gases flow, spinning the turbine even faster and generating more boost. This ingenious use of otherwise wasted energy is what makes turbochargers so efficient and effective at boosting power. Now that we understand how the turbocharger harnesses exhaust gases to spin the compressor, let's talk about how this translates to increased engine power. It all boils down to one simple equation: more air plus more fuel equals more power. By compressing the intake air, the turbocharger forces more oxygen into the engine's cylinders. Oxygen is a key ingredient in combustion, and more oxygen means you can burn more fuel in each cycle. The engine's computer, sensing the increased airflow, adjusts the fuel injection accordingly, ensuring the optimal air-fuel mixture for a bigger, more powerful explosion. This results in a significant increase in horsepower and torque, giving your car that extra oomph when you need it most. It's like going from a gentle breeze to a hurricane of power. Section 5. Turbo. Lag, the delay before the storm. While turbochargers are fantastic at boosting power, they do come with a slight quirk: turbo lag. This refers to the delay between pressing the gas pedal and feeling the surge of power from the turbocharger. Imagine this. You're driving at low speed, then you floor the gas pedal, expecting an instant burst of acceleration. However, there's a brief moment of hesitation, a slight delay before the turbocharger spools up and delivers the boost. That's turbo lag. This lag occurs because it takes time for the exhaust gases to spin the turbine up to speed and generate enough boost pressure. At low engine speeds, the exhaust gas flow is relatively weak, resulting in a slower spool-up time. While turbo lag might not be a deal breaker for most drivers, it can be noticeable, especially in older turbocharged cars. Fortunately, modern technology has found ways to mitigate this lag and deliver a more responsive driving experience. Section 6. Taming the lag: modern solutions for instant power. Car manufacturers are constantly innovating to improve turbocharger technology and minimize turbo lag. Modern turbochargers employ various tricks to spool up faster and provide a more instantaneous power delivery. One such solution is using smaller, lighter turbochargers. These smaller turbos have less inertia, meaning they can spin up to speed faster with less exhaust gas flow, reducing lag. Another technique is twin-scroll turbochargers. These turbos have two separate exhaust gas inlets, each feeding a different section of the turbine. This allows for a more efficient use of exhaust gases, especially at low engine speeds, resulting in quicker spool-up times. Furthermore, some cars now feature variable geometry turbochargers, or VGTs. These turbos have adjustable vanes in the turbine housing that can alter the exhaust gas flow, optimizing the turbocharger's performance across a wider range of engine speeds. These advancements have significantly reduced turbo lag in modern cars, making them feel more responsive and exciting to drive. Section 7. Efficiency champions turbochargers save fuel. You might be thinking more power usually means more fuel consumption, right? Well, here's where turbochargers surprise us again. By harnessing energy that would otherwise be wasted, turbochargers can actually improve fuel efficiency. Remember, turbochargers use exhaust gases to spin the turbine, essentially recycling energy that would have been lost to the atmosphere. This means the engine doesn't have to work as hard to produce the same amount of power, resulting in less fuel consumption. And additionally, smaller turbocharged engines can often achieve similar power outputs to larger, naturally aspirated engines while consuming less fuel. This is because the turbocharger allows them to extract more power from a smaller displacement. So not only do turbochargers boost power, but they can also help you save money at the pump. It's a win-win situation for both performance and efficiency. Section 8, real-world examples, turbocharged powerhouses. Turbochargers are no longer limited to high-performance sports cars. They've become increasingly common in everyday vehicles, from hatchbacks to SUVs, thanks to their ability to deliver both power and efficiency. Take the Ford Mustang EcoBoost, for example. This iconic muscle car packs a punch with its turbocharged four-cylinder engine, offering impressive performance while still achieving respectable fuel economy. Another example is the Volkswagen Golf GTI, a hot hatchback that has been a turbocharging pioneer for decades. Its turbocharged engine delivers exhilarating acceleration and a fun-to-drive experience. These are just a few examples of the many turbocharged cars available today, showcasing the versatility and benefits of this technology. Section 9, conclusion. The future is turbocharged. Turbochargers have revolutionized the automotive industry, offering a way to boost engine power and efficiency without compromising on either. They've become an integral part of modern engine design, and their influence is only going to grow in the future. As technology advances, we can expect even more innovative turbocharger designs that further minimize lag, improve efficiency, and deliver even more power. From electric turbochargers to hybrid systems, the possibilities are endless. So the next time you feel that exhilarating surge of acceleration when you put your foot down, remember the ingenious engineering marvel that is the turbocharger, a true testament to human ingenuity and our relentless pursuit of power and efficiency.